Okay, so we've got to find the values of k for which the following equation have two distinct roots. That means the discriminant b squared minus 4ac has to be greater than 0. If it were to equal 0, there'd only be one repeated root. So here it'll be two distinct roots, so it's going to be greater than 0. So b squared here, k squared minus 4 times a is k times c is 2, and that's got to be greater than 0. So k squared minus 8k has got to be greater than 0. And so I'm actually going to work out the root to start off with. So when k squared minus 8k equals 0, and then compare to this, and that will give me that, factorize this, k times k minus 8 equals 0. Something times something is 0, so either k equals 0 or k minus 8 equals 0, and that says that k equals 0 or k equals 8. So picture of what it looks like. There's 0, there's 8. It's a k squared, so therefore it's going to be a u-shaped curve like so. And we want to find out when is it greater than 0. So when it's a curve above the line y equals 0, all the way here and all the way there. So therefore k has got to be less than 0 or k has got to be greater than 8. Okay, so I haven't got to worry about when k equals 0 because it's not allowed to equal 0. B. Again, b squared is 9 minus 4 times a is k times c is k, and all that should be greater than 0. So it's 9 minus 4k squared has got to be greater than 0. I'm going to solve it when it equals 0 to start off with, and then I'm going to use a graph to work out where my inequalities go. I'm going to add 4k squared to both sides. 9 equals 4k squared. Divide everything through by 4, which will give me k squared equals 9 over 4, and then square root both sides. So k gives me plus or minus the square root of 9 over 4. So k equals plus or minus square root of 9, 3 over square root of 4, 2. What this looks like? Minus 1.5 and plus 1.5. And here we've got a negative k squared. So instead of being a U-shape, it's going to be a hill shape. So, and we want to know when is it greater than 0. So when is it above the line here? So it's all the way here. We have to be careful though, because if k were to be 0, then this would be a linear and there'd only be one root. So k cannot be 0. So it can go from minus 1.5, that's got to be less than k, which is going to be less than 0, or 0 is less than k, which is less than 1.5. So basically anywhere between those things, but it cannot be k. And part C will be b squared. Negative 2k times by negative 2k is 4k squared, minus 4 times a, which is 1, times c, which is 4. And it's got to be greater than 0. So that says that 4k squared minus 16 is greater than 0. Obviously divide through by 4, so k squared minus 4 is greater than 0. Difference between two squares, so I've got k minus 2 times k plus 2. That's got to be, I'm going to make it equal to 0 and find the roots to start off with. Equals 0, and so that means either k minus 2 equals 0 or k plus 2 equals 0. So k equals 2 or k equals minus 2. Little graph to see what it looks like. There's minus 2. There's 2. This one's a k squared curve, so it's back to being the U-shaped curve. I want to know when is it above the line x or y equals 0 all the way here. So therefore k is less than minus 2 or k is greater than 2. That's our things. One final bit. I noticed here that I've got a difference of 2 squareds, k squared minus 4. That's a square number, that's a square number. So I could just go straight into difference of 2 squareds. I could have done exactly the same here, because that's 3 squared and that's 2k all squared. And so I could have just said that went straight to difference between 2 squareds, 3 minus 2k and 3 plus 2k, and that will equal 0. And then therefore k equals minus 3 over 2 or k equals 3 over 2. So I could have done it that way rather than adding 4k squared to both sides. Anyhow, either way, that's done.